Okay, number 8, it says find the equations of the normal to the curve x squared plus 3xy plus 2y squared equals 10 at the points where x equals minus 1. Well, we've got a product here, 3xy, so u will be 3x, v will be y. So that means du dx, so u dash will be 3, dv dx, v dash will be 1 times dy dx. So using the product rule then, v du dx will be 3 times y, plus then u dv dx, which will be 3x dy dx. So if we differentiate this then, we get 2x, that we've got the answer there, plus 3y plus 3x dy dx. That then becomes 4y dy dx, and 10 becomes 0. So if we factorise then the dy dx terms, so my dy dx then becomes, take the other terms over to the side, so minus 2x minus 3y over 3x plus 4y. Okay? So next step then is to discover our coordinates. Okay? Well, x is, the point x is minus 1, yeah? Well, I need to have the y value, don't I? Because to work out dy dx at x is minus 1, it depends on y as well. So I've now got to think about how I'm going to get y. Of course, it will satisfy in this equation 1 if you set x as minus 1, just sub it in there. So when x is minus 1, we've got minus 1 squared plus 3 times minus 1, y plus 2y squared equals 10. 2y squared, take away 3y, okay, minus 9 equals 0. Okay, and then when you solve this, factorize it, you get this bracket here. So that means then 2y plus 3 is 0, or y minus 3 is 0. So y will be minus 3 over 2, or y will be 3. Okay, so we've got 2 points. In this case, we're going to have 2 tangents, okay, which means then we're going to have 2 normals, okay. So at the first point, dy dx, well, if we sub it in there, right, I did this earlier, I got minus 13 over 18, okay, so that's the gradient of the tangent. Now we want the normal, don't we? So remember, m1, m2 is minus 1. So when you play around with that, you get your m2 to be 18 over 13. So that's the gradient of the normal. Okay. So then you use the equation formula then, y minus y1 equals mx minus x1. So y minus negative 3 over 2 equals to 18 over 13, x minus minus 1. Okay, so let's sort these signs out first. Y plus 3 over 2 equals 18 over 13, x plus 1, yeah, because 2 negatives become plus. What I would do now is I take that 13 over to the other side, okay? 13 over to the side here. So we have 13, y plus 3 over 2 equals to 18x plus 1. So all I've done, if you recall, this is how we deal with these fractions here. Don't worry about that fraction yet. That fraction, it's the 13 on the bottom, take it over and multiply this side. So if you multiply out, you get 13y plus 39 over 2 equals to 18x plus 18. Now, of course, we don't really want to have a fraction in our final answer. So if I can get rid of that 2 now, can't I? But what I've got to do is I've got to times through, haven't I, the whole thing by 2. Because I've just got one term divided by 2 here, so we need to double everything, scale everything up. So I get 26y times this by 2, I get 39. So 2 cancels, 36x plus 36. So I get 36x, take away 26y, take away 3 is 0. Okay. Similarly then, if you look at the other point, so if you remember the other solution, we had y to be 3. So at negative 1, 3 dy dx, when I work that out, I get minus 7/9. So that's the tangent, isn't it? So then the normal will have gradient 9/7. And when you work out the equation, then it should come out to be that. That's what I got there, right? Or 9x minus 7y plus 30 is 0. Okay.